What is going on, guys? My name is Amos and I'm back again with another video. So in today's video we want to talk about the limit laws. Now my guess is that you guys have already watched the previous video where we talked about where we introduced the idea of limits in mathematics. So in this video we just want to continue and build on our knowledge. And yep, so what the limit laws are going to help us do is that they're going to help us simplify the calculation of limits, because we're going to think about whatever expression or whatever expression we want to evaluate the limit of. We're going to think of it in terms of sums, differences, products, and quotients, and we're going to apply the respective limit laws that are going to help us solve the problem. So we get that simplified way, we get that simplified, easier form of the expression to deal with. So we're going to start with the first one. Now the first limit law has to deal with what is known as addition. All right, so before we even start, we have to suppose, first of all, we have to suppose that we have two functions, f of x and g of x. All right, and then now we want to suppose that the limit as x goes to a certain a of the function f of x, and the limit as x goes to a certain a of a function g of x. We want to make the assumption that the limits of these two functions are going to do what? Are going to exist, because it is very, very important. When the limits fail to exist, then what we are going to do won't make any sense. All right, so we suppose that the limit of f of x and that the limit of g of x, the two limits have to exist, and we want to take c a constant, and then now we are going to let c be any constant. All right, we want to let c be any constant. Now the first limit law has to deal with addition. All right, so the limit as x goes to a of f of x plus g of x is going to be equal to the limit as x goes to a of the function f of x plus the limit as x goes to a of the function g of x. And then the second limit law has to deal with subtraction, and the limit as x goes to a of f of x, also sorry, here you're supposed to have that addition of f of x minus g of x. This is going to be equal to the limit as x goes to a of f of x minus the limit as x goes to a of g of x. All right, now let me just take care of the top part. And the third limit law has to deal with multiplication, as multiplying two functions. So what is that limit law? And we have that the limit as x goes to a of f of x multiplied by g of x is going to be equal to the limit as x goes to a of f of x plus the limit as x goes to a. We're not supposed to have that plus here. Basically here we have to have a product, because we have a product of functions there. So that's how easy it is to remember these laws. Whenever you have a sum, you have a sum, a product, and of course we must have the limit as x goes to a of f of x multiplied by why am I always getting this wrong? So the limit as x goes to a of f of x multiplied by the limit as x goes to a of the function g of x. Now the fourth one has to deal with I know you guys have already guessed it. It is division. All right, it is division. So we have that the limit as x goes to a of f of x divided by g of x is going to be equal to the limit as x goes to a of f of x divided by the limit as x goes to a of g of x. Now here we have to be very careful, because we have to avoid that division by 0. So our function g of x doesn't have to be equal to 0. So we always have to make sure that any value of x we choose does not render this function equal to 0. All right, we always want to avoid that, because whenever we have a 0 here, we are going to have that division by 0. Yes, so and we want to avoid that always. All right, so let me just take care of the top part and we can look at the fifth one. Now the fifth one, we have to also suppose that let me just get rid of the bottom part as well. Now if we suppose that f of x is equal to g of x, that is for all values of x, now in a certain domain. Now for simplicity, let's take the values of x in the set of real numbers. Now let's assume that f of x is equal to g of x. All right, so what are we going to have now? If you consider that product law, all right, where we have the limit as x goes to a of f of x multiplied by g of x. Now in our case, f of x is equal to g of x, and let's say we multiply f of x n times. All right, so we're going to have multiplied by f of x multiplied by f of x n times. Basically, we're going to have that multiplied by itself n times. So according to the product law for limits, we're going to have that the limit, this is going to be equal to the limit as x goes to a of what? All right, of f of x raised to the power n. That's what the sixth limit law we are going to talk about is this one. Whenever we have a constant and we try to take the limit of that constant as x goes to a certain value a, well, the result is, it's easy to remember, it's always that constant. It's always that constant. All right, and the limit as x goes to a certain a of a function x is going to always be equal to a. Now these are the laws I wanted to present to you guys. Now to make sure that everything is okay, let's do an example together. All right, so we want to evaluate the limit as x goes to -2 of the function x to the power 3 plus 2x squared and -1 divided by 5 minus 3x. Now this is what I was talking about. So we basically have this complicated form of our function. Now we can say this is f of x because the function is defined in terms of f of x. So what we are seeing here is a quotient. So evaluating the limit here is going to be easier because of the limit laws. So we can actually write this in this form. So first of all, we have a quotient. We have x to the power 3 plus 2x squared minus 1 divided by 5 minus 3x. So this is a quotient. And what do we get? All right. Now, first of all, we have to ask ourselves a question. So if I substitute -2 here, am I going to have 0? Well, I'm not going to have 0. So that limit law for division is going to apply because the denominator is not going to be 0. The function g of x is not 0. So we can apply that division law. All right. So we can go ahead with our substitution. So this is going to be equal to the limit as x goes to -2 of x to the power 3 plus 2x squared minus 1. All right. And what else? All right. Divided by the limit as x goes to -2 of 5 minus 3x. Now, if you look at the top separate from the bottom, you're going to see that at the top we have a sum, and then we also have a difference. So if we apply the respective limit laws, we're going to have the limit as x goes to -2 of x to the power 3 plus the limit. Now, of course, the 2 is a constant, so I can bring it here. So I'm going to have the limit as x goes to -2 of x squared minus the limit as x goes to -2 of 1. Now this is going to be divided by, pardon my my division here. So it's not that neat. So we want to take the limit here as x goes to -2 of 5 minus, of course, the 3 is also a constant, so I can bring it here. So you can always do this, and it's not a crime. So x goes to minus 2 over x. All right, so now things look a little bit messy, so I'm going to take care of the top part for you guys. And so what do we have here? So if I substitute minus 2 here, now by, I think that was the sixth limit law, you have to substitute the minus 2 where there is an x here. So we're going to have minus 2 to the power of 3. Now minus 2 to the power of 3 is, now you guys already know it's minus 8. And now 2 minus 2 here, we're going to have minus 2 times minus 2, which is positive 4. Positive 4 multiplied by this constant, we're going to have plus 8. Now minus, and of course 1 is a constant, so we're just going to have that that 1. All right, now divided by, and now 5 is also a constant, and the limit of a constant as x goes to any a is going to be 5. And the limit here, well, what we're going to do here is we're going to put our minus 2 here. Now what are we going to have? We are going to have minus 2 here. We're going to have minus 2. So sorry, here there's a mistake. Now you guys have to forgive me. And we have a minus 1, not a plus 1, but a minus 1. All right, I've corrected the problem. Now in case you guys were wondering why we had that plus, well, it's a minus. So if I put the minus here, I'm going to have minus 2. Now minus 3 multiplied by minus 2, that has to be plus 6. And now you guys are smarter than calculators, so you guys know that this is going to be minus 1 divided by 11. Now this is how you can find the limit of this guy. Now let me give you one example where you guys have to be careful when you're applying the quotient limit law. So let's take this one. So we want to find the limit as x goes to as x goes to 1 over x squared minus 1 divided by x minus 1. Now you guys might be very happy and excited that, oh, this is very simple. Well, we just have to think of this as a quotient because we have x squared minus 1 and we have x minus 1 at the bottom. But guys, look, what we have at the bottom here, if I substitute my 1, notice that this is going to go to 0. All right, so we always want to make sure that our function g of x is always different from 0. Before we even apply the quotient rule for, before we even apply the limit law for division, so we have to first of all simplify a little bit further. Now if you look at the top, we have a difference of squares. So this is going to evaluate to x plus 1 multiplied by x minus 1. And we have x minus 1. Now boom, this guy and this guy simplify. So we have x plus 1. All right. Now, now before we take the limit, this is what we do. And then now we can now evaluate. We can now calculate the limit. So we have that the limit as x goes to 1 of the function x squared minus 1 divided by x minus 1 is going to be equal to the limit as x goes to 1 of the function x plus 1. Now this has to be equal to, now you have to just substitute your 1 here and you should get 2. Now this is, you always have to be careful whenever you're talking about quotients and all that good stuff. Now thank you guys for watching and I'll see you in the next video.